Hello everyone, my name is Ganu Kim, and I'm excited to present my final product, Whisperline Silent Signal School Safety Bot. This is the culmination of our work in CEN 3031 software engineering, and I will be walking you through everything we built. So, before we dive in, let me give you a quick overview of what we will cover today. First, in part 1, I will introduce the project, what Rispline is, and who built it. Then, in part 2, we will do a complete system demonstration. I will walk you through the user experience from login to chatting with our AI counselor, and then show you the admin dashboard. In part 3, we will look at the technical implementation, the architecture, the technologies we used, and our development timeline. Finally, in part 4, I will be transparent about our technical debt, discuss stretch goals for future development, and outline the next steps. So, let's get started. First, let's understand what Whisperline is all about. So, what is Whisperline? Whisperline is a web-based chatbot system specifically designed to detect signs or bullying or school violence. The core idea is simple. We want to give students a safe, anonymous way to express their frustrations and emotional distress. They can talk to a friendly AI counselor without fear of judgment. But here's what makes it special. While students are chatting, our system is analyzing their messages for warning signs. We assess risk levels in real time, and administrators can monitor high risk students through a dedicated dashboard. Think of it as a silent signal. Students get the support they need, and schools get early warning indicators before situations escalate. So, let me introduce the team. First of all, I'm Gonu Kim, and I served as the full stack developer for this project. I was responsible for the front-end UI using React, the backend API with Spring Boot, the GPT integration for our AI counselor, and the project managing. For the tech stacks, I use React with JavaScript and CSS for the front end. On the back end, we have Java 17 with Spring Boot 3.2.0 and Gradle as our build tool. Our database is MySQL, and for the capabilities, I integrated the OpenAI GPT-5 Nano API. Now, let me show you the system in action. So let's move into the system demonstration. When users first arrive as Whisperline, they see this clean login sign. The login interface is straightforward, just username and password. Below that, we have a link for the new users to sign up, and there's also a separate link for admin access. So after clicking sign up, let me show you the sign up process. When a student clicks sign up, they are taken to a registration form where they will enter their name, choose a username, create a password, and provide their email address. So once they submit all of their personal informations, the account is created and stored in our MySQL database. They can then log in with their new credentials. And just like that, they're into the chat interface. This is basically the heart of the Whisper line, the chat interface. As you can see, it looks like a familiar messaging app. The students can type in their messages here and hit send. And let me send a text message saying something like, I've been feeling really anxious lately and I really don't know the reason why. And here's the response from our AI counselor. Notice how it acknowledges the student's feelings and offers coping strategies. what you don't see on the student side is that behind these screens, our system has accessed this message and assigned it a risk level. In this case, it might be around something like 15 to 20 row risk, but still untracked. Let me try another message. So I've been having thoughts that scare me. So waiting for the AI counselor's response. Let's see how they see the AI response approximately, offering to develop safety plans. This message would have a higher risk level, maybe around 45, and it'll appear on the admin dashboard. The AI is trained to detect warning signs including self-harm, violence, suicide ideas, and other concerning patterns. So, moving on to the admin scene. Now, let me show you the admin side. I'll log in with the admin credentials, and this is the admin dashboard. The first thing administrators see is the real-time risk alerts section. This table shows the top 10 most recent high-risk messages, specifically any message with a risk level above 30. For each alert, we display the timestamp shows as a relative time like 2 hours ago or just now, and the student's username and the names. A preview of the message, the risk level with the color coded badge. The color coding is intuitive: green for low risk, yellow for medium, orange for medium high, and the red for high level. This allows administrators to quickly identify students who may need immediate intervention. So below the alerts, we have the top 10 users by average risk levels. While the alert shows individual messages, this section identifies the students with consistently elevated risk levels over time. We calculate the average risk level across all of the students' messages and rank them. This helps identify students who might not have one dramatic messages but show a pattern of concerning behavior. We also show the message count so that administrators can see how much data we have for each student individually. So, we all show the message count so administrators can see how much data we have for each student. There's a refresh button here to get real-time updates. Now, let's look under the hood at how we built this. So, here's our system architecture. We have a three-tier architecture. The React frontend communicates with our Spring Boot backend throughout the REST FUI APIs, and the backend persists data to a MySQL database. Additionally, the backend connects to the OpenAI GPT-5 Nano API for generating counseling responses. Let me walk you through the key API endpoints. For authentication, we have post endpoints for sign up and login. For the chat's functionality, there's a post endpoint that sends the user's message to our GPT service and returns the AI's response. And for the admin dashboard, we have two GET endpoints, one for the top risk user analysis and one for the recent risk alerts. All of these endpoints are secured with CORS configurations for out front-end origin. This slide shows our development timeline through Git commits. We start with the initial project setup, creating the React frontend and Spring Boot backend structure. Then we build out the basic UI components and established the backend API structure. A major milestone was integrating the GPT-4 APIs for counseling responses with risk assessments. We later optimized this by switching for GPT-5 Nano for cost efficiency. We added MySQL database integration, implemented the user authentication, and creating the login and sign up UI. Chat message persistence was added so we could track convenient conversations over time. Finally, we built the admin dashboard with the risk analysis and real-time alerts. In total, we made 19 commitments throughout the development process. Let me highlight our key technical achievements. First, the GPT integration with custom prompt. We carefully crafted a system prompt that gives the AI a counselor persona and specifically trains it to detect school violence and safety concerns. We also implemented response format validation to prevent prompt injection alert attacks. Second, our risk assessment systems calculates risk levels from 0 to 100 in real time and validates the response format to detect potential jailbreak attempts. Third, we achieved full-stack integration with clean REST FUI API communication between React and Spring Boot with MySQL persistence. Fourth, the admin analysis dashboard aggregates user risk statistics and provide risk real-time monitoring capabilities. Now, let's begin transparent about what we didn't get to and where we'd like to go. First of all, every project has a technical debt, and here's ours. Password hashing. Currently, passwords are stored as plain text. In a production environment, we would absolutely use bcrypt or similar hashing. JWT authentication. We are using simple session-based authentication. JWT would provide better scalability and security. WebSocket real-time updates. The dashboard requires manual refresh. WebSocket would enable live updates. Email notifications. We plan to alert administrations via email for high-risk messages, but didn't have time to set up the infrastructure. Other items include user profile management, message history, pagination, dynamic admin user management, detailed risk reports, multi-language support, and mobile responsive design. These were all planned but deprioritized to focus on core functionality. Looking on forward, here is our strict goals for future development. For security, we've implemented bcrypt password hashing, JWT authentication, and role-based access control. For real-time features, WebSockets integration would enable live messages updates and push notifications for high-risk alerts. For for analytics, we add detailed risk trend analysis, export capabilities to PDF and CSV, and schedule email reports. For user experience, mobile responsive design, dark mode, and multi-language support. And for AI improvements, we've added conversation context memory so the AI remembers previous messages, more numerous risk categories, and integration with existing school counseling systems. Let me share our current issues and next steps. So the current issues, the GPT-5 nano model uses significant reasoning tokens internally, which requires us to set a high max completion tokens value of 4,000. This affects response time and cost. Admin credentials are currently hard-coded, which isn't ideal for production. Admin creates so there's no section persistence, so users are logging out page refresh, and CORS is only configured to localhost. Immediate next steps, and we have the long-term roadmap. So we'd love to partner with the school district for pilot testing, integrate with existing school safety systems and multi-school support with separate dashboards, and implement FERPA uh, compliance measures for student data projection. So, thank you. This is the end of the presentation, and really thank you for listening. Thank you.